Hey guys, it's Miss Parrish. I'm coming to you to talk to you today about our lesson on polygons in the coordinate plane. You do have some guided notes that you will need to have pulled up and completing as we go through this video. As always, you can pause the video if you need to take time to fill something in or you get behind. So, as always, have your notes up and pause this anytime you need as we go through this lesson on polygons in the coordinate plane. Our essential question is how can you solve problems by drawing polygons in the coordinate plane? And this goes with our standard 6G3. Just a quick review, what is a polygon? A polygon is a closed plane figure formed by three or more line segments that meet only at their endpoints. So these are just some examples of different types of polygons. A triangle is a polygon, just basic shapes like we covered in our area unit. Rectangles, squares, trapezoids, rhombus, triangles, all of those are polygons. A circle is not, because a circle is not line segments. It is just one consistent circle or one consistent line making the circle. So you can see some examples here of items that are and are not polygons. Another vocabulary term that you will need to be aware of that's very important is vertex. A vertex is the point where two sides of a polygon meet. So it's kind of like the points, as you can see here on this triangle. On the rectangle, you can see there's four corners or points. So the vertex is where the two sides meet. They can be represented as ordered pairs. The polygon can be drawn in the coordinate plane. So basically a vertex are the corners or the points, okay? So as you can see, a triangle has 3 points, and that's also the same number of sides that it has. A rectangle has 4 vertices or points, and that's also how many sides it has. So the plural for vertex is vertices, if you heard me use that word. All right, so our first example, this is Explore Activity 1. Sheila wants to make a pattern of 2 different tile shapes on a floor. She first graphs the shapes on a coordinate plane. So let's look at this with the coordinate plane here. So the first thing we need to do to help her out is we want to plot the points to form the tile shapes. Now, this lesson is using items from our previous lesson on distance in the coordinate plane. We'll be using coordinate plane throughout this lesson. So hopefully you're still familiar with that. This is the coordinate plane as we talked about before. We talked about the other day in our previous lesson. Each section is a quadrant. You have your x-axis and you have your y-axis. Now, remember these numbers in parentheses are called your ordered pairs. And that's the numbers we use to plot a point. It's like the directions. Remember when we plot a point, I know some people have still been confused. When you plot a point, we go across the x-axis first, either to the left or to the right, and then up or down. We called it dribble and shoot, okay? So make sure you are putting these in the correct spot. So if I'm going to plot these points, the first point, point A, is the ordered pair 3, 5. So that means I'm going to go over to the 3 and then up to positive 5, okay? And I'm going to label that point A. Okay, always label them. Point B is positive 4, positive 6. So again, start at your origin, dribble over to the 4, go up to the 6. Put the letter B with that one. Point C is 5, 5. They're both positive, so I'm going to go over to positive 5, up to positive 5. So that point is going to go right here. Make sure you're plotting these on your notes. Point D is positive 4, positive 4. So again, I go over to positive 4, up to positive 4. Dribble and then shoot. Label that as a D. Once I plot these, it next tells me to connect the points. So I'm going to connect using my computer at home, so it's a little different there. When I connect these, they want me to identify the polygon. So what is this? If you'll notice that it does have four sides, um, my drawing is not the best, but if you'll look carefully, you will see that all four sides have the same measurement. So that makes this a square. Okay, it makes this a square. Kind of could look like a rhombus, but it is a square. Okay, pause this if you need to finish that. The next part of this problem, we've got some more points to plot to form the other tile shape. So just like the previous slide, we're going to plot these points and then connect them and identify the polygon. Okay, so if you want to pause this and try that on your own for a second, and then you can come back and do it or check it with me. All right, hopefully you paused this and got this completed. Point P is negative 5, 2. So I'm going to start here. Negative 5, remember we go across first. So up one over to negative 5, up to positive 2. So point P is going to be right there. Be sure and label those points. Q is negative 4, positive 3. So dribble over to negative 4. Shoot up to positive 3. There's the Q. R is 0, 3. Now, since the first number is a 0, that means I do not go either way, left or right. I stay right here on the axis, but I will shoot up to the 3. So that one goes right there. That is point R. Point S is positive 1, positive 2. Point T is positive 1, negative 2. So I'm going to go down for that one. U is 0. So again, I do not go left or right, but I go down to negative 3. V is negative 4, negative 3. So over to negative 4, down to negative 3. That's not a very good V. And my last point is W, negative 5, negative 2. Okay, so now I'm going to connect my points in the same order that I plotted them. So P, Q, luckily they go in order of the alphabet. That makes it easy. You could have connected them as you plotted it. Each one, you could have done that if you wanted. I apologize that it's not perfectly drawn. I'm using my computer at home, so it's a little difficult. So now that we've connected these, now this is a shape we've not really dealt with before. But if you count the sides, 1, 2, 3, 4, 5, 6, 7, 8, some of you may know what an 8-sided shape is. It is actually, this is an octagon. Okay, octo means 8. Think of an octopus, the animal. He has 8 arms or legs or whatever they're called, tentacles. Octo means 8, so an octagon has 8 sides. Okay. Now, our reflect question says, how is the number of vertices related to the number of sides on the polygon and the top of polygon? Give 2 examples. So look back to what we did here. The square has 4 vertices and it also has 4 sides. The octagon has, remember the vertices or the vertex points are your corners. This one has 1, 2, 3, 4, 5, 6, 7, 8 points, and it also has 8 sides. So how is the number of vertices related to the number of sides? They are the same, okay? And it talks about, give 2 examples. So you could say the number of vertices and sides are the same. Okay, 2 examples. We could even use a triangle has 3, and we can do the octagon that we just talked about. You can do any 2 shapes you want. I'm just going to do those. Okay. So the number of vertices is the same as the number of sides. Okay. So you can pick any two shapes you want. So pause this and fill that in your notes. Okay, before we get to the next section, just very quickly, let's talk about perimeter and area. We touched on this at the beginning of our area chapter or unit. Remember, perimeter is the distance around a shape, the measurement around, where area is the measurement of the inside, the area that's covered. Okay, perimeter is like if you're putting a fence around something, area is like if you're putting a carpet down on the floor. Okay, so for perimeter, you add all the sides together. For area, you use the area formula depending on whatever shape you are working with. So if you have that orange formula sheet, that can be handy for this. All right, so we want to find the perimeter in the coordinate plane. Says you can use what you know about finding lengths in the coordinate plane to find the perimeter. Okay, so let's practice one. This example you should have in your notes says the grid shows the path Tommy followed when he walked from his home at point 00. It gives you all the coordinates right here, but his home at point 00 to various locations and then back home again. If each grid square represents one block, oops, how many blocks did he walk? Okay, so here you've got all of your locations listed: home, library, park, friend's house, pond, and store. You have the coordinates of each of those things. Home is your origin. 04 would be your library. The park is 54, so that must be the park. Friend's house is 52. Pond is 72, and store is 70. So that's all of the locations. So this is showing, all of the places he went. Okay. Apparently, he started at home, then he went to the library, the park, his friend's house, the pond, the store, and back home again. So they want us to find the perimeter or how many blocks he walked. Okay, so you can work this a couple of ways. If you've got the graph in front of you, you can simply count all the way around. I think on your notes, they're wanting you to kind of break it down in sections. So when he went from home to library, let's count how many blocks that he walked. 1, 2, 3, 4. So I think on your notes, you've got to type in the 4. And then from the library to the park, he walked 1, 2, 3, 4, 5 blocks. From the park to his friend's house, 1, 2 blocks. From the friend's house to the pond was 1, 2 blocks. From the pond to the store was 1, 2 blocks. And then from the store back home was 1, 2, 3, 4, 5, 6, 7. So we've counted and all of the blocks that he walked to each location. So now you just want to add those up. So if you add those up, 4 plus 5 is 9. 9 plus 2 is 11. 11 plus 2 is 13. 13 plus 2 is 15. And 15 plus 7 is, I'm going to go down here where I have more room, 22 blocks. You want to put your label blocks with this because that's what they're asking. So 22 blocks is the perimeter of the area he walked. Okay, let's try another example here. This says this grid shows the path Lisa followed when she walked from her home at 01. So this is her home to various locations and back home again. If each grid square represents one block, how many blocks did she walk? Well, when she went from this location to that location, that's 1. And then she went 1, oops, sorry about that. 1, 2, 3, 4. Then from this location, sorry, I don't know why that keeps popping up. Sorry about that. 1, 2, 3. Then 1, 2, 3. 1, 2. 1, 2. 1, 2, 3, 4, 5, 6, and then back home. Now, you know, in a perfect world or on a TCAP test, you could probably just sit here and count all the way around. I think your notes has blocks for you to fill in, so that's why I kind of wrote these out this way. So let's add these up. 1 plus 4 is 5. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 2, 13. 14, 15. 15 and 6 is 21. 21 and 1 is 22 again. Okay. If you didn't have to fill in all that, you could have just simply counted all the way around and it would have totaled 22 blocks. Okay, so that's finding the perimeter. So now they want you to try it here for Tommy. Suppose the next day Tommy walks from his home at the mall at 08, then walks to a movie theater at 78. After leaving the theater, he walks to the store before returning home. How far does he walk? Now, you're going to have to plot these on your graph, okay? So we're going to say that Tommy went from his home to the mall at 08. So 08. I'm going to guess that that is the mall. He walks to the movie theater at 7, 8. Okay, we'll call that the theater. After the theater, he walks to the store at 7, 0. So that's the store. And then home is obviously 0, 0. All right. So you can connect those if you would like. Okay. And then you can do this a couple different ways. I'm going to show you two quick ways. First way is to count like we did in the previous examples. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay, so 8 plus 7 is 15. I'll do a little shortcut here. 15 and 15 is 30. So 30 blocks. Okay, so you can just count the directions there on the graph. Okay. Now, you could also use the absolute value format that we did the other day. That's a little more complicated. So if you have a graph, just count and total the blocks there. Okay. So that's finding perimeter. Just count and add up all the sides of the shape. Area has a little more, complex formulas here, but you can still do it very easily if you'll follow the formulas. Says you can use familiar area formulas to find the area of polygons in the coordinate plane. Okay, so here are all the formulas. If you don't have your orange sheet, if you have it, you can have it out if it's handy. If not, you can just use these formulas here. You can flip back and forth or jot them down on a piece of paper so you don't have to flip back and forth. Just remember the formula for square and rectangle is length times width. Parallelogram, base area equals base times height. Triangle area equals 1/2 base times height. The rhombus area equals 1/2 diagonal 1 times diagonal 2. And the trapezoid is area equals 1/2 times the height times the sum of base 1 and base 2. These should be familiar to you since this was in our last unit. All right, so let's look at our first example here. Okay. Says Caleb is planning a new deck for his house. He graphs the deck as a polygon labeled A, B, C, D, E, and F on a coordinate plane in which each grid unit represents 1 foot. The vertices are as follows. Those are the ordered pairs. What is the area of Caleb's deck? Okay, so the first thing you would have to do on this is graph point A, point B, point C, point D, point E, and point F. Good news for you, it's graphed for you. Okay, If it was not, the first thing you would need to do is graph the points. These would be the steps that you would have to follow. I think you need to type these into your notes where there's steps listed, okay? First thing would do, if it's not already graphed, you would have to graph the points. Then you connect them in the same order you graphed them, okay? They must be in the same order. Now, if it is a complex shape, you're going to want to divide it into two familiar shapes. If it's just one shape, then go for it. But as this one, you can see here, it is two shapes. It is a complex shape. So we would divide those just like when we did complex shapes in our area unit. Okay, all of this we've done before. Then you want to find the length, width, base, height, whatever you need to know for your formulas for each shape. Then use the correct area formula, just like when we did complex shapes. You find the area of this shape and then find the area of this shape. And then once you find the area of both shapes, you add those two together. So this is just like when we did area of complex shapes in our last unit. The only difference is your shape is on a coordinate plane this time. Okay, so same concept here. So this is already graphed. Check. They're already connected. All right, so now we want to divide them into two shapes. I'm going to just go ahead and you can see where that little dividing line is there. Okay, so now let's look at the two shapes we have. This top shape is going to be a rectangle. Okay, so remember, just like we did before, we're going to write the name of the shape. It's a rectangle. What is our formula for area of a rectangle? Area equals length times width. Okay, so we always remember when we did our lines on area. All right, so let's just start with the rectangle here. Let's start with this one right here. I'm going to outline it so it stands out for us. Okay, we have a rectangle. Area equals length times width. So now I have to get the measurements of the length and the width to know what to multiply together. So if I will look at my rectangle right here, this can be my length from B to E, can be my length, and then from C to B or even D to E, either one of those sides can be my width. Okay, so let's count for my length. I'm going to go from point to point. Okay, 1, 2, 3, 4, 5. So my length is going to be 5. My width from point to point, again, I can do C to B or D to E. They're both the same. 1, 2, 3. So my width is 3. All right, so that one was 5 and that one was 3. So I don't even need a calculator for that. I know that 5 times 3 is 15. Okay, so this is going to be, I think it told us, oh yeah, each grid represents 1 foot. So this would be 15 feet squared. Okay, so that's the area of the rectangle. Now I need to find the area of the other shape. So I'm going to erase this so don't confuse it with the other shape. Now, if I look at this shape, looks kind of like a leaning rectangle. And if we remember from our area formulas, this would be a parallelogram. That would be another reason it would be good to have our orange sheet handy so you could confirm the shape if you're not sure. Okay, as we saw on the previous slide, area of a parallelogram is base times height. So for this one, I need my base. It can either be the B to E or the A to F. Okay, those are going to be the same distance. All right. We know from a minute ago, 1, 2, 3, 4, 5, that is 5. That can be the base. Now remember, the height is not the slanted line. Remember, we talked, you'd never use the slanted line. My height is actually the line that's going to form that right angle. Remember, the height runs up like that, perpendicular. So my height is going to be 1, 2. So I have 5 times 2, which is 10 feet squared. So I've done everything so far. I found the measurements. I used my formulas. And then just like when we did complex shapes before, you find the area of each formula and then add both of them together. So 15 plus 10 is 25. So my final answer, the area of this complex shape, is 25 feet squared. Okay, like I said, this is nothing totally new. We've done this in the area unit. So if you need to pause this and catch up, go ahead. Okay, sorry, I was trying to see how many more we had to go. All right, so let's do another example real quick. They are giving us the vertices of this polygon. Notice they're calling them polygons. They're not telling us what shape it is. Okay, we got to figure that out. So we're going to plot the points. Remember our steps from the previous example. Let's plot our points. A is 0, 0. I'm going to label that. B is 2, 2. Now this graph makes it a little easier. Over to 2, up to 2. I only have one quadrant, so that makes it a lot easier. C is, oops, I may have to move my letter B there for a second. Point C is positive 2, or, oh no, sorry, 2, 6. Okay, I'm going to connect as I go. That might also, okay. D is 7, 6, so dribble over to the 7, shoot up to the 6. E is 7, 2. Oh, that's a terrible line. Doing this late at night, so sorry. And then F is 9, 0. Okay, so connect these. All right. So when I look at this one, they want me to find the area of this one. Now, I'm going to divide this into two shapes. That is a very unusual shape. Almost looks like a hat now. All right. So I've got a rectangle on top, and that would be a trapezoid on the bottom. So let's do the rectangle first. Knock out the easy part. Length times width. So for my rectangle, I've got 1, 2, 3, 4, 5 times the width 1, 2, 3, 4. So the area of my rectangle is 20. It's not telling me what the units are, so we'll just say units squared. Okay, so there's my rectangle. So now remember the trapezoid's that long formula. 1/2 times the height times the sum of base 1 and base 2. Okay. 1/2 times, now on my trapezoid, my height is going to be this little line right here. So it's going to be 1, 2. Okay. Remember my bases are the parallel sides. So in this case, my bases are going to be the top and the bottom. Remember, we never use the slanted sides. So this first base is 1, 2, 3, 4, 5. My bottom base is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember when we solve the formula for area of a trapezoid, we do the parentheses first. 5 plus 9 is 14. So now I can take half of 2. That should be easy. Half of 2 is 1. 1 times 14 is 14 units squared. And remember, since this is a complex shape, the last thing I do is I add the 20 plus the 14, and I get 34 units squared. Okay, again, we're just doing complex shapes. They're just on a coordinate plane. Okay, pause it if you need to catch up. Last example, I'm going to do one more. Let's again start by plotting your points. Point L is at 1, 2. So go over to the 1 and up to the 2. Okay. Point M is 1, 6. Go ahead and connect that. N is 7, 6. So go over to the 7 and up to the 6. O is 7, 2. So go over to 7, up to 2. P is 5, 0. So that means I go over to the 5 and I don't go up or down. And then Q is 3, 0. Over to the 3. Since it's a 0, I don't go up or down. Okay, this looks like it's going to be another rectangle and trapezoid. Okay, let's start with the formula for rectangle. Length times width, just like the last one. We're going to go 1, 2, 3, 4, 5, 6. The length can be 6. Just count across. The width, 1, 2, 3, 4. Remember, we're just doing the rectangle, so you don't want to count everything. And then we know 6 times 4 is 24. Trapezoid is that long formula. Again, we can't seem to get away from it tonight. All right. Now remember on the trapezoid, our bases are the two parallel sides. So these are going to be our bases. I'm trying to make it stand out a little bit since I can't change the color. Our height is going to be this line that connects the two bases. Okay, so my height is going to be 1, 2. My bases, 1, 2, 3, 4, 5, 6, and 1, 2. Okay, remember you do parentheses first. 1/2 times 2 times 6 plus 2 is 8. So now I'm going to take half of 2 again, which is 1. And 1 times 8 is 8. So now I found the area of the trapezoid is 8. Remember, last step, add the 24 and the 8 together, and I get 32 units squared. Remember, we do not know if it's feet or anything, so we can use the word units squared. That is how you find area and perimeter of polygons in the coordinate plane. Okay, please make sure that you complete your guided notes and submit those. You do have an assignment in Google Classroom that you need to complete. Please show your work when you're adding for perimeter, when you are using formulas to find area. Make sure you're showing your work on those for your teacher. Follow the instructions that your teacher has placed in the Google Classroom. As always, if you have questions, please contact Mr. Harden, Ms. Klein, or myself, whichever one of us is your teacher. We will be more than happy to help you. And I hope you guys have a great rest of the day.